do more on factors that affect reaction rates today. We're going to do a green-red rotation. In the red, I'm actually flipping this. In the red, we're doing the pre-lab experiment number 11, and in the green, we're going to work on Learn Smarts. Okay? So because Learn Smarts seem to be not needing as much help as the other part. So we're going to go through, whoops, need to go back up to the front. We're going to go through the lab. Now this lab, it takes it's a pretty hefty write-up to start with. It's going to be working with reaction rates, and there's A, B, C, D, and E parts. A through D have to do with what we call clock reactions. And clock reactions are reactions when you mix them together, they change color after a period of time. And you're going to mess with different things going on with that. You're going to have to be familiar with that. So when we come back from break, we have 1 day to finish up equilibrium is what we're going to be doing that day. And the next day is your lab day. And then the day after that is half lab, half review, and then the test. And we're done with this semester. So we want to make sure that we are done with Learn Smarts. We are done with homework before we go to break, because there's really not going to be a lot of time to do that after break. Equilibrium, I think you'll be okay with, but if there's some problem and you don't quite get through all the homeworks, but you got most of the homeworks done, when we come back from break and we talk about equilibrium, it should click really fast. You should be able to do that really quickly, okay? But I really want you through your Learn Smarts and at least most of the way through all the homeworks, because when you come back, we do have to do some review and get going. So on this lab, parts A through D, you need to look through, really become familiar with. I have rewritten the procedures for you so they're not as muddled as they are in the book. Okay? So hopefully that will make some sense to you. If you have questions, go back to the book and see if you can find it. On part E, you get to, okay, so let's first of all review. What affects the rates of reaction? There's 5 things. Who remembers? Temperature. Okay. Concentration. Yeah. Okay. So that sort of goes in with temperature, because more hits, more chances to get the right. Okay, so we got temperature, we got concentration, particle size, okay, catalyst, one more. Nature of reactant. Are they really going to react at all, or if ever? Okay, so we did that with, when we looked at those equations, which ones would react, which ones react slow, which ones react fast. So when you get to part E, you are going to test temperature, particle size, and concentration. And you're going to have 3 experiments that you get to choose how you're going to test those. But one needs to test for temperature, one for particle size, and one for concentration. I'm going to show you those today, but we're going to go through them first on the board. And as we go through them, you need to talk to your partner, whoever it is, and decide how you're going to test them. Okay, all these tests that we do in lab are going to need 2 people, one that's mixing and one that's timing. So, is everybody here today? No. Kayla's not here. So, you 2 going to be partners, and then you're going to have to get Kayla up to speed. Okay, so as we go through, so we're going to be testing this. You're going to be looking at the different ones. The first one that we're going to that I'm going to show you here in just a minute is reacting sulfuric acid with sodium sulfite. And this is done in a Petri dish. And in a Petri dish, on the lid, you put a drop of indicator, and inside you put a drop of indicator. The one on the lid is a reference color. The one inside will change colors as sulfur dioxide from the reaction gets into the air in such a concentration that when it hits the liquid, it turns into sulfuric acid. This one, if you have contacts on, you have to be very careful with, because if the sulfur dioxide hits the liquid in your eyes and you have contacts on, it holds it against your eye and can burn it. So when we're done with this one, this is a precaution I forgot to write in that would be one of your safety things from on your white paper that you need to write down, is you do not want to open the lid of the Petri dish until water is running, and you put it right under running water. So it will grab any of the sulfur dioxide and put it right into water. On the opposite side, in the Petri dish, you're going to mix the sodium sulfite and the sulfuric acid, and then, like I said, it will give off sulfur dioxide and then change the indicator color. So that's one of them. And I do give you the reaction for that one because it's a little bit tricky because you have a decomposition thing going on this side. On the other part here, will you do me a favor while you've got that on, run down to the copy center and grab there should be some, just like 5 copies of their study guide. Okay, thanks. And then go back and do that. Thanks, I forgot to tell you that. Okay, next one is reacting magnesium ribbon with hydrochloric acid. And you do this in a well plate, and you'll have the ability to have distilled water, magnesium ribbon, the hydrochloric acid, and the well plate to play with. And we'll talk about that as we go through. That one you have to write your equation on your own. This one, the next one is a seltzer tablet with water. On this one, we're going to use a film canister. We're going to test for the height that it will go. We're going to test for the time that it takes for it to go. So there's 2 things that you're testing on that one. All right, so when you get to write up your thing, you're going to have a paper like this. I'm okay for you to write in pencil because you're going to be trying to figure things out, going back and forth on this when you're doing your procedure and setting up your data table and that. But your conclusion and your graph should be done in colored pencil. Conclusion should be done in pen. Okay? I have not broken the conclusion down for you to claim, evidence, and justification. You need to do that yourself. Okay? Now, as we look at this, you are going to have a balanced reaction. You're going to have a problem. Every time you look at the problem is going to be how does concentration affect reaction rate? How does temperature affect reaction rate? How does particle size affect reaction rate? That should be part of your claim. My claim is that particle size affects reaction rate, da-da-da. What's your evidence? What from the lab told you that was true? Justification. How did the evidence prove your claim? Okay? So when we go back there, the hypothesis is your educated guess. What do you think is going to happen? Is it going to get faster? Is it going to get slower? Is it going to whatever? Anybody know what IV is? What's IV? It's your independent variable. It's what you are changing. So when I ask for an IV, it's your independent variable. What did you change? What are you going to change? The dV is your dependent variable. Okay, IV goes on the x-axis. dV goes on the y-axis. Okay, dependent variables, what's going to change because of that? So it should be time, right? For the one that we're doing with the film canister, you'll have time and height that should be changing. Okay, constants. Everything else should be held constant. So anything else you're using in that reaction should be held constant. You have your procedure. No, you do not have to use all those numbers. You can make more numbers if you need to make more numbers. Okay, but please make it so on your procedure, somebody else in the class can pick up your paper and do the experiment like you wanted it done. Okay, so make sure you're very precise on how you're writing your procedure down. Data table, make sure that you've got that set up so you know what data you need to get from lab. What do I need to write down? What is going on? Okay, and your graph, you also should have your axes set up. Now, when you go to do that, you need to make sure that everything is done, and you have to clear that with me. So all your pre-lab has to be done and approved before you can do the lab when we come back from break. You can get that done all the way up until we go to do that. You do not want to be waiting that day for me to prove it the day that we start lab. You need every minute in lab. Okay, so it's got to be approved before we hit the lab day. And the lab day for that is the, let's see, we come back on a B day, which is Wednesday, and you start your lab on Friday. Okay, so you could possibly get together with your partner over the break and get it to me on Wednesday to be approved, but it's going to be tight. Oh, okay. Wow, I picked the wrong copy sheet. Okay, so what we're going to do is we're going to actually look at each of these. So as we go, the first one that we're going to talk about is the Petri dish one. And so I'm going to put a Petri dish here. I'm going to turn my light on, get it to focus, and hopefully come into focus here. There we go. And I've got a lid and a Petri dish. Okay? We are going to be using for this one sulfuric acid, an indicator, universal, and sodium sulfite. Okay? First thing I want to do is my indicator. I want to have one inside and one outside. It looks like I did 2 drops. So whatever you do as far as the indicator, it needs to be consistent. So I did 2 drops on each because I couldn't not squeeze it. Then you want to put one of them down. Now this is important on this one. You need to have the same number of drops. So if you're changing concentration and I want to have a total of 6 drops, I could do 1 drop of one and 5 of the other. Or I could do 2 and 4. Or I could do 3 and 3. Or I could do 4 and 2. Or I could do 5 and 1. So I want to have minimum of 3 trials because I want to be able to see the trend. 3 is the absolute minimum. 4 is better. 5 is even more good because you can see trends better. Okay? If you look at the R value for something that has 3 points, it's a lot worse than the R value for a line that has 5. Okay? You can actually get closer to what you need to do. So I'm going to say that I'm going to use 6 drops. Just to be consistent here, I would be doing this several times, but I'm going to do 3 drops. And this is where your partner comes into play because they would have to start timing the minute I do a drop, and I've got to have this one ready to go on. So I've got to put 3 drops in here as fast as I can and then put this on. Now, as we're watching here, I'm going to see if I can get there. So you can see the green without the light on it. We sit here and watch it, and we're timing it. You have to decide between you and your partner, when are you going to call it? Okay, so I'm going to zoom in just a little bit so we can see those greens a little bit better. You've got to decide when you're calling it, because if you look right now, you can start seeing the outside going a little bit orangey yellow. Do I call it now, or do I wait until more of it's orangey yellow? Or do I wait until it's all orange or yellow? Or do I wait until it's all dark orange? So I've got to make sure I'll decide when we're stopping it. Because if we stop it at different times, then it's not consistent. Our results are going to be bogus. Okay? So you've got to decide, okay, I'm going to wait until all the green's gone. Or I'm going to wait until I first see the dark orange appear, or whatever. Okay? Just be consistent, because as long as you're consistent, you'll be able to get a good answer. Okay? This one you want to clean up right away, because if you don't clean it up right away, it actually stains the Petri dish and it causes a lot of problems. And you don't want it to keep producing the sulfur dioxide. Okay? So, really quickly with some extra water, I'm just going to put some extra water in there just to get it rolling in here so I don't get the stain. I would normally take it right over to the fountain and get rid of it. Okay, or the sink. On the next one, it actually is, okay, stop. I need to stop myself. Stop, talk to your partner. What one could you use that for? Which one would you like to use it for? You can use buckets or ice cream lids to put this Petri dish on ice or in hot water or in cold water. You could change the concentration. You could, particle size, probably not so much. So while you do that, I'm going to take this over and get it cleaned up real quick. So I believe it has you write down what could you use it for, what are you going to use it for. You might want to wait for what you're going to use it for till the very end after you see all of them. Okay, have you written down what you could use it for? The other thing that I forgot to tell you about with this one, before you do your next experiment with this Petri dish, you need to make sure it is wiped out and completely dry, because if there's any water, it's going to affect your results. Okay, so we'll have paper towels back there and you can wipe it out. Really good. All right, next one. This one is, I'm going to zoom in on just one or two wells. Let's try focusing it so we don't look. Maybe I zoomed in too far. There we go. I was like, maybe I don't have my glasses on right. For this one, we're going to use concentrated hydrochloric acid, and you can't see it. And we're going to use magnesium ribbon. So you'll be given a strip of magnesium ribbon, and you've got to decide how many trials you're going to do, how much magnesium ribbon you're going to use for it. I'm just going to use a small amount, about that big. Okay, so that's my fingertip. It looks awful under that. Okay. You're going to need to decide how many drops you're going to want in a well. A well will hold about 30 drops nicely, so you don't want to go over 30. You also don't want to dilute the concentrated acid, because you'll have distilled water you can dilute it with, more than halfway. So whatever you use, don't dilute it more than half, because it will not work, or it'll take an awful long time. Okay, so I'm just going to put some in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So 30 fills the well about halfway. So you might be able to get away with 40, but we're going to do 30. What you're going to do here is you're just going to, you could take your little piece and cut it up into tiny, tiny little pieces and different variations of size for particle size. You could do concentration. You could put the well plate on ice. You could put it on a hot water plate to change the temperature. So on this one, when you put it in, you're looking for how long it bubbles or effervesces. It works a lot better on the black, so don't put white under this one. On the Petri dish, I would get a paper towel and put white underneath it, because it's a lot easier to see the color change with white under it. This one you do need to be careful with too, because it gives off hydrogen gas, but some of that gas coming off is actually the hydrochloric acid that has been vaporized. So you don't want to be leaning over it and breathing it or getting it in your contacts. So just sort of stay back and watch it until it stops fizzling, and you're going to time it and be done. And this one can just be rinsed down the sink, because it works really well as a drain cleaner. Okay? All right. Talk to your partner about this one. What do you think you want to use this one for? What might be best for that? You guys don't talk much. Okay, got talked. Okay, on the next one, bring it up here a little bit. We're actually going to use, see if I can zoom out. Oh, there we go. A film canister. On the side of the film canister, there'll be marks: 1/4, 1/2, 3/4. You need to decide how much water to put in. Okay, I would keep it consistent with the water. Don't try and change the water amount, because it makes it very hard to be consistent. I would not choose anything more than 2/3. Okay, you're going to have problems if it's more than 2/3. Okay, you're going to have this, and you'll have a lid, and you'll have an effervescent tablet given to you, and the effervescent tablet will be like this. Remember that you want to do at least 3 4 is better or 5 is even better. So I would try and just take this very carefully and break it in half, and then break it in half again, so that you can do 4 trials. About a fourth will give you, this will be the excess. So you don't need to worry about it. You'll notice some of mine are a little bit bigger than others. It's okay. If I wanted to try and make it more fair, I'd probably take a little bit off that and put it with that. Okay? So it's not going to be an exact thing. It's going to be as best as you can break it. Okay? Now for this one, you're going to be able to have a mortar and pestle that you can break up into little pieces or to slightly pieces or whatever. You also can use the hot water, cold water. I'll have boiling water and I'll have ice. Let's see. Concentration is going to be hard on this one because this is a solid and we have to use liquid. So the concentration is going to be hard to do with this one. All right, so what we do with this one is we're going to be going in between where you go into the school here and the second doors because it's high. It goes all the way to the top. Unless it's a nice day, then we can go outside. But today is sort of freezing and it'd be miserable. But that's where we're going to go. You're going to take and you're going to fill. If it were me, I would have everything ready to roll. I'd do my hottest ones first because if something's cool, it doesn't really matter. But if something's hot, it will give away heat really quickly. So do your hottest ones first. Go to your coldest ones last. If you're going to do the temperature, if you're going to do particle size, just get all of your particles in little cups, weigh cups, to take out with you with some water so that you can refill and redo real fast. You're going to be measuring bricks, how high it goes, and you're going to be measuring how fast. Okay? So if I take one of these and I just put it in here, that's how I put it when I go to put it down. You'll have an ice cream lid that you'll have down here. I was going to try and video this, so we're going to turn this and see if I can just at least get somewhat of a video going. All my messy stuff right here. Zoom out. Wrong way. Try this way. Okay, so I'm down on the lower thing here. Let's see if I can move it out here so you can see a little bit anyway. Just get these out of the way. Okay, so here we go. We're going to take this. I've got the tablet in here and I've got just about a half full of water. And you take and really quickly put it on, turn it upside down on its lid. That way you can track it a lot better. If you try and put it with the lid up, it's really hard to follow the lid when it flies. And the hotter the water, get away faster. And you will need to wear safety goggles with this one because we've had it go up in people's faces before. Okay, so you will be timing this and seeing how long it took for it to go. So you can see if we did in here, it has a lot more energy than we can measure how high it goes. All right? So that is the end of the demos for the different types. You need to take the time now. We're going to do rotations. If you're in the green, I want you to grab a computer, get started on your LearnSmarts, your homeworks, and A&S. If you're in the red, we're going to be working on the pre-lab and getting some help, getting it written up. And we'll switch at about halfway through, so we've got about a half an hour in each one, just under a half an hour in each one. Okay? Okay, time is yours.